Hello everyone. My name is Noah Fukumoto, and I am from Cybernetics and Reality Engineering Laboratory at Nara Institute of Science and Technology, Japan. The title of today's presentation is an object synthesis method to enhance Visuo-Haptic consistency. Normally, we manipulate virtual objects with a VR controller, such as a Vive controller. However, there is a problem in that the shape of the virtual object and the shape of the controller differ, making a natural sense of touch impossible. For example, on the left, you have a virtual gun, and on the right, you have a virtual sword. The sense of touch, on the other hand, will always be provided by the same VR controller. As a result, the actual sense of touch you will experience will differ from the expected sense of touch based on the appearance of the virtual object. This difference is referred to as Visuo-Haptic inconsistency. To address Visuo-Haptic inconsistency, haptic devices with actuators have been extensively studied to present haptic sensations that are consistent with the appearance of a virtual object. However, it is difficult to provide high degrees of freedom with arbitrary shapes. In addition, such haptic devices are generally large, require special equipment such as an air compressor, or cannot be attached or detached by the users themselves. So, such haptic devices are not always suitable for casual use. So, we propose to use a real object around us that has a similar shape as a haptic proxy for the target virtual object. For example, we can use an umbrella as a virtual golf club and a tennis ball as a virtual apple. They are expected to produce more consistent haptic sensations than a VR controller. However, using a real object as a haptic proxy may not completely solve the problem of Visuo-Haptic inconsistency. This is because the shape of the real object that users will touch may not be exactly the same as that of a virtual object. For example, the shape of the handle of a spatula on the left is bulging in the middle and has a hole at the bottom, which is slightly different from the grip of a virtual bamboo sword on the right. That is why haptic discomfort may still occur due to the Visuo-Haptic inconsistency. In this study, we propose a chimera object, an alternative virtual object to improve Visuo-Haptic consistency. A chimera object combines the shapes of a real object and its corresponding virtual object. Then, we report on a user study that demonstrated the effectiveness of a chimera object. Finally, we propose an interactive chimera object creation system for end users, and report on another user study that demonstrated its effectiveness. I will now describe the chimera object in more detail. A chimera object is designed to improve the Visuo-Haptic consistency between a virtual object and a real object. So, the shape of a chimera object is generally identical to that of a virtual object. Only the part of the chimera object that the user will touch is deformed to that of the real object seamlessly with no visible seams. In this way, a chimera object will be visually similar to the original virtual object, while its appearance where the user will touch is consistent with the haptic sensations that the real object will produce. For example, a chimera object in the middle is generally similar to the virtual hammer on the right, and it has the same grip shape as the real spatula on the left. A chimera object is synthesized from a virtual object and a 3D reconstructed real object. As a first step, we subdivide each triangle and resample the vertices of the two objects to regulate the vertex density. After adjusting the number of vertices, we perform a principal component analysis for each object, and then align their origins and axes so that all the vertices are represented in the same coordinate system. The next step is to find vertex matching between the two objects so that every point on the real object has a corresponding point on the virtual object. Finally, a new vertex of the chimera object is generated between each vertex pair with an appropriate weight, and its surface is created using Poisson surface reconstruction. The vertices of a chimera object are closer to the real object for the part the user will touch and closer to the virtual object otherwise. We investigated the effectiveness of a chimera object and the effect of alleviating haptic discomfort. In this evaluation, we measured the sense of haptic discomfort experienced during two interactions, one with real objects and an unprocessed virtual object, and the other with the same real objects and the corresponding chimera objects. We expected that the participants would feel less haptic discomfort with the chimera objects. There are two types of object touch, dynamic touch and static touch. Dynamic touch is generated when a probing motion is applied to an object. Static touch is generated when grasping an object without hand motion. We modeled a dagger to examine both dynamic touch and static touch. Participants will touch its tip to experience dynamic touch, while grasping its handle to experience static touch. To give a variety of levels of Visuo-Haptic inconsistency, we created 12 different real objects by using a 3D printer. As shown on the left, they are a combination of 4 types of tip shapes, i.e., ideal, sharp, round, and chamfer, and 3 types of handle radius, 10 mm, 15 mm, and 20 mm. To correspond to these 12 real objects, 12 chimera objects were synthesized as shown on the right. Next, I will explain the experimental design. Participants were asked to wear a head-mounted display, grasp the handle of a real object with their dominant hand, and touch the tip with their non-dominant hand. After 1 minute of the experience, they were asked to answer a questionnaire on Visuo-Haptic consistency, and repeat the task for all the 12 real objects. They performed the procedure in 2 conditions. In original condition, they saw the original virtual object all the time. In chimera condition, they saw each of the 12 chimera objects corresponding to the real object they were manipulating. 8 male participants in their 20s participated in the evaluation. These figures show the level of participants' perceived Visuo-Haptic consistency. The left figure is about the static touch and the right figure is about the dynamic touch. As these red boxes indicate, we found a statistically significant difference when the handle radius was 20 mm and when the tip shape was chamfer or round. In these conditions, chimera objects alleviated the haptic discomfort. When the tip shape was ideal, they felt less consistency with chimera objects. This is probably because Poisson surface reconstruction sometimes produces roughness on the surface. No statistically significant differences were found in other conditions. So, overall, these results show that chimera objects improve Visuo-Haptic consistency. So far, the experimenter has determined the weight distribution of a chimera object. However, optimal weight distribution will depend on each individual. We believe that the user in the loop framework is crucial for the success of a chimera object. Therefore, we propose an interactive chimera object creation system for end users and evaluate its effectiveness. We implemented a user interface that allows the user to assign deformation weights to each vertex of a chimera object. To specify the weights, the user can paint an object in grayscale from 0 to 1. The brighter the pixel values, the more similar that part is to the shape of the virtual object. And the darker the pixel values, the more similar the shape is to the real object. We also implemented an affordance-based initial weight estimation. First, we render the virtual object from 64 different viewpoints. Then, we estimate the grasping part in each image by using affordance net. We then generate 64 mask images by painting the grasping part in black and the remaining part in white. Next, we assign the color to the corresponding vertices by using the depth buffer we used for rendering the images. Finally, we apply a smoothing filter by considering the mesh distance and normalize the color so that it ranges between 0 and 1. Here, we show the chimera object creation system in use. The figure on the left shows the graphical user interface in which the user can specify the weights by painting the object directly or interpolating the 2 specified points at once. The figure on the right shows how a chimera object is seen in the virtual environment. The user iteratively adjusts the weight and confirms the chimera object in VR until he or she is satisfied. We investigated the effectiveness of the chimera object creation system. In this evaluation, we asked participants to create a chimera object in 10 minutes from given models. We measured the level of Visuo-Haptic consistency they felt and the level of usability using the system usability scale. 8 participants in their 20s participated in the evaluation. Here are the real and virtual objects we used in the evaluation. A real screwdriver and a virtual bamboo sword were used in the practice. We prepared 2 tasks, A and B, for the main study. In Task A, A real spatula and a virtual hammer were used. In Task B, a real banana and a virtual gun were used. Each participant did one task with the unprocessed virtual object and the other with the chimera object they created. They did the two tasks in a randomized order and combination. The left figure shows the level of participants' perceived Visuo-Haptic consistency. We found a statistically significant difference in Task B, where a real banana was used for a virtual gun. In this task, chimera objects alleviated the haptic discomfort. On the other hand, no statistically significant differences were found in Task A, where a real spatula was used for a virtual hammer. This is probably because the grip shapes were somewhat similar to each other from the beginning. The right figure shows the level of visual comfort. No statistically significant differences were found, so they felt that chimera objects were not visually less comfortable. Overall, these results show that the participants could create satisfiable chimera objects by using the chimera object creation system. This figure shows the result of the system usability scale scores. The average score for the system was 69.375, which is slightly higher than the General SUSE standard score of 68. The result suggests that our system had a moderate level of usability. In this study, we proposed and evaluated chimeric objects. Chimera objects complement haptic sensations when we use a real object around us as a controller. Our first evaluation confirmed that chimera objects improve Visuo-Haptic consistency. We also proposed and evaluated a chimera object creation system. It supports chimera object creation by iterative weight adjustment and NVR confirmation. Our second evaluation confirmed that our system allows novice end users to create satisfiable chimera objects with moderate usability. Thank you very much for listening.